All right, we're looking at what's called Binomial Experiments, section 4.2. Okay, here's a textbook. We'll look at some of the stuff in the textbook. But here's a binomial experiment. There's four things what a binomial experiment is. One, it has a fixed number of trials, where each trial is independent of the other trials. And what that means is, you do something over and over and over, and each time it has the same probability. Like maybe shooting a free throw, you either hit it or you miss it. But you have the same probability every time you shoot it. If you flip a coin, getting ahead, each time you flip it, you got the same probability. All right, number two, there are only two possible outcomes. It's called binomial. The key on here is bi, which means two, and there's only two possible outcomes. Either a success or failure is usually what we say. Success or failure. Okay, that's our two outcomes. Number three, the probability of success is the same for each trial. That's what I just mentioned. If you have a bag that has 3 red marbles and 2 blue, okay? If I reach in the bag, and what's the probability I get a red marble? Well, it's 3 out of 5. If I don't put it back, that's going to change my outcome. All right, so that wouldn't be binomial. Binomial is it has the same probability every time. Okay, it's independent. And then the fourth thing, random variable x counts the number of successful trials. So like N is usually how many times you do this. So like maybe you do it 10 times, like shooting a free throw 10 times. All right. And suppose you hit 6 of them. X would be 6. Okay. And here's the notation that we're going to use. N is the number of trials. So like I just said, suppose N was 10. I don't know. Okay. P is the probability of success in a single try, so the probability that you hit the free throw. Q is the probability that you fail, that you don't hit the free throw. And right here, 1 minus P is what Q is. So suppose you got a 65% chance that you hit the free throw, then that means Q is going to be 1 minus that, which is 0.35. So that would be P and Q. And then X, as we just said, that's the number of successes. Okay. All right. So here you can see we've got some cards we're drawing, and I think on this binomial experience was getting a club. What's the probability of getting a club? All right. So like here, fail. Here's a club. That's a success. Fail, fail, and then here's a success. So in this one, we did it 5 times. So N is 5. X would be 2 because there's 2 successes. All right. All right, so look here. Identify whether these are binomial experiments or not. So like right here, a certain surgical procedure has an 85% chance of success. A doctor performs the procedure on 8 patients. The random variable represents the number of successful surgeries. All right, this sounds like it is binomial. It's a binomial experiment. P is 85%. There's 8 patients, so N equals 8. X would be how many successful, like, I don't know, suppose of the 8, 7 of them were successful. Then X would be 7. So this is binomial. Okay, now look at this one, number 2. A jar contains 5 red marbles, 9 blue marbles, and 6 green marbles, kind of like what I just talked about a minute ago. You randomly select 3 marbles from the jar without replacement. All right, that's going to kill it right there. That's going to kill it. Because if you pick a red one, all right, what's the probability you get a red one? Well, for the first one, okay, there's 5 red ones, so there's going to be 5 of those out of 5, 9, and 6. So that's a total of 20. But on the second one, I'm not replacing it, which means there's only 4 now, and there's only 19 total. So see, my probabilities are not the same there. They're different. And in a binomial, it has to be the same every time. They have to be independent. Now, if it said with replacement, then it would be okay probably. All right. And here's the solutions for those. Okay, so we're going. All right, so here's the main thing of this: the probability of doing this experiment. And we see right here, now we've already talked about this in class, combinations of n things choosing x. Then we have our p, which to the x power, p is our probability, and then q, probability of a success, and then q is the probability of a failure. And this may be, I don't know, you may not understand it. This right here is the combinations. We didn't really talk about this. We just punched them in the calculator. We just did this in the calculator. But here's what you're doing when you do a combination. All right, but look at this example here. This, I don't know if I can get it all on the screen, but rotator cuff surgery has a 90% chance of success. The surgery is performed on 3 patients. So there's 3 patients. Find the probability of the surgery being successful on exactly 2 of them. So exactly 2 of them. What's the probability to have success on 2 of the 3 surgeries? All right, so here's a little tree diagram. So this is the first patient right here. See, the first surgery. It's either success or a failure. All right, then you got your second surgery right here. All right, it's a success or a failure depending on if the first one was a success, or it's a success or a failure depending on if the first one was a failure. Then you have the third surgery, which is success or failure depending on this, success or failure depending on that, and so on. And so there's 8 different outcomes here that we have. Okay, so here's all the outcomes. Success, success, success. Success, failure, success, success, failure. Success, failure, success. Success, failure, failure, and so on. There's 8 different outcomes, and here they all are. Okay. So 3 successes, that'd be 90% or 9/10 times 9/10 times 9/10, which is this. But now what we're looking for is exactly 2. Well, here's exactly 2, and here's exactly 2. These 3 right here. So they come out to be these 3 right here. If you notice, it's going to be success 9/10, success 9/10, and the failure, well, that's 1/10. And I multiply those together, and there's my probability. Okay, so here's the probability for this one, here's the probability for that one, and here's the probability for that one. So if I add those together, that's going to be 243 over 1,000. Okay, now suppose I do this with the formula that I just showed you right there. Okay, all right, so here, just write this down here. All right. All right, so there's 3 trials, which means n equals 3. There's 2 successes, which means x equals 2. Okay. The probability of success is 0.90, which means q is going to be 1 minus that, which is 0.10. So here's the 4 things we need, and put over here, that way they're all lined up. Here's the 4 things you need right there. Okay, so what I'm going to have in here, my probability of x is going to be, probably a 2 actually, it's 2. All right, so it's going to be 3c2 times 0.90 to the 2 power times 0.10 to the 1 power. Okay, now what this means is n is 3. There's 3 total surgeries here, and there's 2 we desire to be success. Okay, and then this is my success percent, or my success probability. I do that to the 2nd power. This is my failure probability, and I do that to the 1 power, because if I have 2 successes, that means I have to have 1 failure. And I multiply these together. All right, so if I do that, okay, it'll be like this right here. So I'm going to do 3c2, so 3 in CR2 times, and then we'll have 0.90 to the second power. Then I'll have 0.10 to the 1 power. And then there you go, 0.243. That's what I get right there, which is what this is. This is 0.243. So when I divide it by 1,000, just moves the decimal over 0.243. Okay, and you can see it right there in the answer. There's the answer. Okay, now we're not going to look at that. All right, here you go. This is in a survey. U.S. adults were asked to identify which social media platforms they use. The results are shown in the figure. 6 adults, we got 6 adults here, who participate in the survey are randomly selected and asked whether they use social media platform Facebook. Construct a binomial platform distribution for the number of adults who responded yes. So if you look at the little thing here, here's Facebook, 68%. All right, so that would be our P. So I'll write this down then. So on this one now, okay, struggling, P is going to be 0.68, which means Q is going to be 1 minus that, which is 0.32. All right, there's 6 adults in this, so that means N equals 6. Now X equals, well, X could be 1, X could be 0, 1, 2, 3, 4, 5, or 6. It doesn't tell us what to look for on this. We just got to build the whole thing. All right, so it's telling us right here. There you go. There's P, there's Q, like we just said, and N is 6. And so X could be all these values there, like I just said, okay? All right, so here's how we build up this probability distribution. So the probability that none of these people, see, of the 6 people, we're going to ask them, hey, do you get on Facebook? Do you get on Facebook? Well, this is the probability that none of them do. All right, so it's going to be 6 to 0 of the success percent to the 0 power, and then the failure, since none of them do, all 6 are failing. And so I multiply this up, and I get that right there. Here's 1, so it's going to be of the 6, X would be 1. See, this is what X is right here, these numbers here. So this is 0.68 to the 1 power, and then 0.32 to the 5 power, because that means there's 5 failures. If there's 1 success, that means there's 5 failures. And that's what I get here. Here's 2, C, it's a 6C2, and then the success percent to the 2nd power, and then the failure percent to the 4th power, because since there's 6 people and there's 2 success, there's going to be 4 failures. And so that's how you do this, okay? You might study this a minute, maybe put it on pause and look at it for a minute. I don't know. Okay. All right. And then here's the thing. If I take all of these right here, which there's 7 of them, there's 7 because N is 6. So 0 to 6, 0, 1, 2, 3, 4, 5, 6. See, there's 7 of those. And if you add these 7 up, it should equal 1. And notice that each one of these probabilities is between 0 and 1, and if I add them all up, they equal 1. Okay. Here's one here. A survey found that 17% of U.S. adults say that Google News is a major source of news for them. You randomly select 4 adults and ask them whether Google News is a major source of news for them. Find the probability that exactly 2 of them responded yes. All right, so that's the first one. Number 2, here's a different one. All right, so the probability that 2 responded yes. Okay, here, I'm just going to do this right here. So in this, P is 0.17. Okay, that means Q equals 1 minus that, which is 0.83. My decimal is right there. I don't know why I did that. N equals, all right, how many was in this? Lost my number. All right, 4, right there it is. 4 adults, so N is 4. Okay, and then it says, for number 1, exactly 2 of them respond yes, so X would have to equal 2 here. All right, so there's my 4 things I need. All right, so that means I'm going to have this then. The probability that 2 of them say that it is a good source for them. It's going to be 4C2 times, and I'm going to have this percent here, which is my success. I'm going to have that to the second power times, and I have 0.83 to the second power. Since there's 4 people and 2 success, it means there's got to be 2 failures. And I multiply this up. All right, so if I do that now, 4, okay, 4 NCR 2 times 0.17 to the second power times 0.83 to the second power. Oh man, I'm in the, oh darn it. Messed up there. All right, to the second power. I didn't space over and get out of the exponent. And then times 0.83 to the second power. And that is 0.119. Okay, that's my probability of 2 of these people. And you see right there, right, man, right on it. So in other words, what this means, of these 4 people, what's the probability that 2 of them say yes? Well, right there, that's the probability 2 of them say yes, right there. Now, look back at the question here. It says, number 2, at least 2 of them respond yes. At least 2. Now, what does this mean? At least 2? That means 2 or more. All right, so we've got 2 right there. Now what we need to do is we need to figure out what 3 is. We need to figure out what 4 is. So we've got to do these the same way we just did that one. Now, what's cool about this is when you type this on the calculator, okay, I want to change this to 3. I can just go right back into my calculator where I had typed this in, and I can change this to 3. I'll change this to 3, which means I have to change that to 1, because if there's 3 successes, it means there's 1 failure. So I can just, look here, I just go right back in my calculator to that right there, and I can just change those numbers, which is a lot easier than just typing it all over again. All right, that should be a 3. Oops, and that should be a 3. All right, there you go. That's not very much, is it? So it looks like it goes back 4 places. So 1, I got 0.0003. That's what I got for that. Okay, and then the probability for 4 is what it's asking. I can just, like I said, I can go back in here and change this to a 4. Change this to a 4, and then this would be a 0. Okay, so 4. Oh. Okay, go back in here. I forgot what I was doing. Oh, there's, yeah, I didn't think that was right. See there, I had a 21. I need to delete that 1 right there. So we had a mistake on that. I didn't think that was right. Yeah, that looks more like it. 0.14. Yeah, 0.14 is what that should have been a while ago. Okay, made a mistake there. I didn't realize that was on the calculator. All right, so, oh, no. That was supposed to have been a 1, not a 2. All right, so 0.16. 0.016, not that one. I'm messing up, sorry. All right, so this should be a 0. This should be a 4. That should be a 4. And that comes up to, all right, that's not very much. So make sure I didn't make a mistake on this one. No, I think I'm good. All right, so that moves over 1, 2, 3, so that's going to be 0.0008. All right, so at least 2 means I add the 2, the 3, and the 4. I add these together. So I've got 0.016, I got 0.0008, and then I got the what was the answer for the first one a while ago? 0.119. So I just add those up. Because here's 2, here's a probability for 2, here's a probability for 3, here's a probability for 4, and I would add these together because the question asked 2 or more. So I'd add all 3 of these. So let's see here. 0.119 plus 0.016 plus 0.0008, and I get 0.1358, which would be 0.136, I believe. All right, let's see if we got that right. It says 137. Okay. I may not have added them right. I'll go back later. I'm not going to do it right now. Okay. Now the third says fewer than 2 of them respond yes. All right. Now I'm not going to do this one, but it says fewer than 2. That means 0 or 1. So I would do 0 and 1 and add them 2 together. Okay. All right. We're not going to do this page. Now graphing them. When we graph these, here's a graph right there. Okay, and so we just make this little histogram and we find our probability. So we find each trial, 0 through 6 in this case, and we graph our probabilities on the side. So you can see here 0, 1, 2, 3, 4, 5, 6. There's 6 entries in this. Okay, or 6 participants. N equals 6. Okay. All right. Then we get to this right here. The mean, the variance, and the standard deviation. So the mean is, this is the average. And the standard deviation, that tells you how the numbers fluctuate as far as like from the average to the left or to the right. Okay. So the mean is N times P. The variance, which is sigma squared, is N times P times Q. And the standard deviation is the square root of the variance. Okay, so we'll do one of those. Oh, here it is, right here. Here's a problem. In Pittsburgh, Pennsylvania, about 56% of the days in a year are cloudy. Find the mean, variance, and standard deviation for the number of cloudy days during the month of June. Okay, so P is 0.56. That means Q is going to be 0.44. I do 1 minus that. All right, N. In a year, we're talking about in a year, so that's going to be 365. And then X would be 1, 2, 3, all the way up to 365. Okay. All right. So it says find the mean, the variance, and the standard deviation. All right, the mean, we just talked about that. The mean, which is mu, okay, that's going to be N times P. So N is 365, and P here is 0.56. So multiply those together. Okay. So, here we go. 365 times 0.56, and I get 204.4. 204.4. There's mu. All right. The variance, which is sigma squared. Okay, let me get it on the screen here. Okay. That's going to be N times P times Q. All right, so I can just take N, 365 times P, which is 0.56, times Q, which is 0.44. Oh, me, what did I do there? I got in the exponent somehow. All right, so N, 365, times P, which is 0.56, times Q, which is 0.44. And I get this right here, 89.936. And then my standard deviation, I do the square root of that answer. Well, son of a gun. Okay. We'll do the square root of that answer, 9.48. That's my standard deviation right there. Which means the average of this is 204, but it fluctuates 9.48, which means most people are going to be 204 plus this or 204 minus that. They'll be in that little range. That's what the standard deviation means. Okay, and so let's see here. We got I think we did this. This isn't a year, but I don't think this is the right. Because this says June. I think we got the wrong answers here for that problem. Yeah, I think we do. Okay, well, let's go on to some of this homework. So here's our homework problems we're doing, all right? So that's just explaining what's going on here. So number one, in a binomial experiment, what does it mean to say that each trial is independent of the other trials? Okay, each trial is independent of the other trials if the outcome of one trial does not affect the outcome of any other trials. This is it right here, A. What that means is, when you roll a die, and say you got this one die, okay? Here's your die. Okay, this is a 3, and that's a 2, and that's a 1. And of course, it's got 3 other sides. And suppose you roll and get a 3. All right, when you pick it up and roll again, you have just the same amount chance of getting a 3 the next time. And there's no difference in the probabilities every time. The chances are the same. So that's what independent means. Okay, number 2 here. All right, the following histograms each represent binomial distributions. Each distribution has the same number of trials n, but different probabilities of success, p. Okay, it says over here, match p equals 0.3, 0.5, and 0.6 with the correct graph. Okay, so you got 3 graphs here. Now what I would do is, I would look on here and see, like, all right, if you look at 0, look at where 0 is here. It's got a high probability. This is not as high, and of course this is low. So what I'll do is I'll just do 0 and figure out which graph is based on those probabilities. So let's do this one first. There's 3 different ones to do here. Okay. If you look at the graph though, each one of these graphs has 4, n equals 4 because there's 4 people in this. So n is 4. We're going to do 0, so it means x is 0. My p here, it says 0.3, which means my q is going to be 0.7. Okay, so I'm going to type that in. So here's what I'm going to type in, okay? I'm going to use those numbers. So for this first one, I'm going to do the probability of 0, which means I'm going to have, was it 4 again? Yeah, n is 4 right there. Here's 4 NCR 0 times 0.3 to the 0 power times 0.7 to the 4 power. Okay, that's what I'm going to type in. And what's cool about this is when I do 0.5, I can just change 0.3 to 0.5. All right, so let's type this in. I got 4 NCR 0 times 0.3 to the 0 power times 0.7 to the 4 power. Okay, what do I get here? I get 0.2401. Okay, now let me make a note here. This was 0.3. Okay, now let's do 0.5. So basically, I'm just going to leave my calculator there, and I'm just going to go change my 0.3 to 0.5, which means I have to change my q from 0.7 to 0.5, because that's what 1 minus that. So I get 0.0625. And I'm going to do 0.6, right? Yeah, 0.6. So I'm going to go back up here. I'm going to change my 0.5 to 0.6, which means this needs to be 0.4 now. And what do I get there? 0.0256. So there's my 3 probabilities. All right, the highest one clearly is this one. So the 0.3 is this one. And then look at these remaining 2. This one's lower, which means that's the 0.6 there, and that's the 0.5 there. So according to this, that's A. A was 0.3, B is 0.5, and C down here is 0.6. Okay. All right, number 3 here. Here's some more histograms. Match n equals 4, n equals 8, and n equals 12 to the correct graph. Each histogram shown below represents part of a binomial distribution. Each distribution has the same probability of success p, but different numbers of trials n. Okay, so, all right, look here. This goes from 0 to 12. So right here, n is 12. But on this one, see, this just goes to 4. So n is 4 here. Whereas this one, this goes from 0 to, this is 8. So the first one's 12. The second one was 4. Third one was 8. Okay. Now this next one says, what happens as the value of n increases and the probability of success remains the same? Okay, well you go from 4 here to 8, and then you go to 12. See how it expands? It goes from this to this to this. And it looks like the more trials, it looks like it gets more symmetric. So it looks like to me. So it looks like I think it's B right here. As n increases, the distribution becomes more symmetric. Okay. Here's some more histograms. Number 4. The histograms each represent part of a binomial distribution. Each distribution has the same probability of success, p, but different numbers of trials, n. Identify the unusual values of x in each histogram. All right, so unusual. This looks like unusual right here because there's not very much of that. See, here's 0.5 right there, 0.05, and it's less than that. Anything less than 0.05 is considered unusual. So it looks like 0 in that one. So we're going to select 0 here. That'd be my answer there. Now in this one right here, I think this is B. Yeah, n equals 8 it says. Okay, these two here look unusual, and I think this one right here is unusual because it's below that, and it also looks like 8 is. See, they're all below this line. This line right here is 0.05, which is considered unusual. So this looks like 0, 1, 2, and 8. So as I select my answer, I think I will select C. 0, 1, 2, and 8. And then what's unusual in this one? Well, it looks like all of these, 0, 1, 2, 3, 4, and then 11 and 12. 0, 1, 2, 3, 4, 11, 12 right there, B. That's my answer. Okay. Number 5. Find the mean, variance, and standard deviation of the binomial distribution with the given values of n and p. All right, so here's n, 90. Here's p, which means q then is going to be 1 minus that, which is 0.8. All right, so find the mean. All right, the mean is n times p. So I just do 90 times 0.2, which is 18. Okay, here. All right, so again, I'm going to do n 90 times 0.2, which is 18. Okay, remember now, mu is n times p. This is n times p times q. So I'm going to do, let's go back up in here, times 0.8. And there you go, 14.4. That's my variance. My standard deviation is going to be the square root of that answer, 3.79, which rounds to 3.8. So you see my answer is right here, 3.8. Now what does that mean? It means the average, the mean is 18. But if I can add 3.8 to that, that'd be 21.8, or subtract, that'd be 14, is it 14.2? So that means between these two numbers right here, that's where most of our people are going to lie, because it's within 1 standard deviation of the average. Okay, number 6 is the same thing. NP, it means Q is going to be 1 minus that, which is 0.15. All right, so what's the mean? All right, this is n times p. I multiply these two right here, so it's going to be 127 times 0.85, which is 107.95. Okay, find the variance. All right, that's n times p times q. So multiply all three of those. All right, 127 times 0.85 times 0.15. And that comes up to 16.2. 16.19, but it rounds to 2. Now, all right, and I got to find the standard deviation now, which is the square root of that. Now, what I would do, I would just do the square root of this. I wouldn't do the rounded one because it might be off just a little bit. Go ahead and do the square root of this answer, even though you rounded it for your, son of a gun, I keep doing that. Okay. Let's get this back on there. Now do the square root of that answer. Keep hitting the wrong button. So that's 4.03 or just 4. Okay, let me see my answers are right down here. All right. Number 7. All right, 7 says, about 30% of babies born with a certain ailment recover fully. A hospital is caring for 7, we got 7 here, 7 babies born with this ailment. The random variable represents the number of babies that recover fully. Decide whether the experiment is a binomial experiment. If it is, identify its success, specify the values of n, p, and q, and list the possible values of the random variable x. All right, so I think this is binomial because they're either they recover fully or they don't recover fully. So there's only 2 things here. So I think this is binomial experiment, yes. What is a success? I think the baby recovers. Okay. Specify what n is. All right, n is 7 because there's 7 babies. Okay. Specify the value of p. All right, the p is right here, 30%. So this is 0.30. What's q? All right, for q, I do 1 minus 0.30, which is 0.70. And it says list the possible values of the random variable x. All right, well, x could be 0, 1, 2, 3, 4, 5, 6, 7. It could be this right here. Oh, no, I'm sorry. This one, because it's got to have 0. I didn't notice that it didn't have 0 on it. Okay. So it means you could have 0 that fully recover, 1 that fully recovers, 2, 3, 4, 5, 6, all the way up to 7. All 7 could fully recover. That's what the x means, okay? All right, and there's my answers. Looks like we're in good shape. Okay, here's another one, same kind of question. A state lottery randomly chooses 5 balls, number 1 through 36, without replacement, and right there is keyword no. No. You're not replacing it, which means your probabilities are going to be different. See, there's 36 balls. So if you get the right one, it's a chance of 1 in 36. But for the second ball, if you get the right one, it's 1 out of 35 because there's only 35 balls now. So the probabilities are different. So it's not a binomial experiment. So it's not because you're here. The probability of success is different for each child. That's B, no. All right. Identify a success. Well, a success is matching the numbers, but this is not binomial, so it's D. And then specify n, p, and q. Well, it's not binomial, so we can't have a p and a q like that. This possible values of the random variable x. Well, again, it's not binomial, so we can't do that. So that's kind of easy, wasn't it? Number 9. A survey asked 2,000 workers, has the economy forced you to reduce the amount of vacation you plan to take this year? Well, 24% of those surveyed say yeah. They are reducing the amount of vacation. 10 workers Participating in the survey are randomly selected. So there you go, right there. We see N is 10 right there because they're selecting 10. 24%. P is 20.24. Q, 1 minus that, is 0.76. All right, now let's go on here. The random variable represents the number of workers who are reducing the amount of vacation. Decide whether the experiment is binomial. If it is, identify success, specify the values of N, P, and Q. We already got those. And list the possible values of the random variable X. Okay, so yes, this is binomial. Okay. All right. What's a success here? I guess we're looking at the workers who are reducing the amount of vacation, so I guess it's this one. N, we already just wrote that down, it's 10, because there's 10 workers that's selected. And 10 workers are selected in this. P, we just said our P and Q right there, 0.24. All right. And then our Q, 0.76. And then what's the possible values of the random variable X? Well, it could just start at 0 and it go all the way to 10, so it's this one. Okay. And we got them all. Look at that. All right. Okay, number 10 here. 48% of U.S. adults have very little confidence in newspapers. You randomly select 10 U.S. adults. Find the probability that the number of U.S. adults who have very little confidence in newspapers is exactly 5, at least 6, or less than 4. Okay. Let me get a piece of paper here. All right, so in this problem, looks like P is 0.48 right there. Okay, which means Q is going to be 1 minus that, which is 0.52. Right there is N. N is 10. And then what we're going to do is we're going to do 0, 1, 2, X, 3, 4, 5, 6, 7, 8, 9, 10. Here's all the different values of X. Here's what X could equal. Okay. Now, this is find probability of 5. So we're going to do 5 right here. So let's just do 5. Okay. All right. So it's going to be a combination. Well, there's 10. N is 10. And we're doing 5 here. Okay. My P is that's 48. I was in a hurry. So 0.48 to the 5th power, because we have 5 successes, which means I got 0.52, and I'm going to have 5 failures since there's 10. So that's what I'll type in. So let me type it in there, okay? So we've got 10 C5 times 0.48 to the 5th power times 0.52 to the 5th power, and I get this right here at 0.244. All right, so that's this one here, 0.244. We got it right there, man. We see the answer. Okay. Now, look at this one. It says find the probability that X is greater than or equal to 6, which means 6, 7, 8, 9, 10. There's 5 of those. All right, so what I have to do is I've got to do 6, 7, 8, 9, 10. I got to do all 5 of them and then add them together. Okay, so this one's going to be 10C6. Then we'll have 0.48 to the 6, and then this is going to be 0.52 to the 4. Okay, this is going to be 10. Here, let me put equals in there. 10C7. And this is going to be 0.48 to the 7, and then this will drop down to 3. Okay, and so I'm not going to write them all out, but that's how they go. I'm going to type this first one in, and I've already got this 5 in there, so I'm just going to go back into it and change my answers. This last decimal, or last exponent, should be a 4. This should be a 6. And this should be a 6. So there you go. There it is. See how fast it goes when you have just 0.188. Okay. Go back in there and we'll change this to a 3. Change change that to a 7. I hope you can see this okay. Let's see if I can pull that up a little bit. Okay. And then we'll change it to 7, and there you go, man, 0.099. Okay, and then 8. All right, we'll go back in there. I'm going to change it to 2. This would be 8. That'd be 8. And that's 0.034. And then 9. I'm going to go back up in here. Change this to 1. Change it to 9. Change it to 9. And I get here 0.007. And then 10. Change it to 0. 10. And then change this to 10. And there you go. I got this -4 means I move it back 4. So 1. I got 3 zeros and a 6. Okay. So there you go. I add all them together. So 0.188 plus 0.099 plus 0.034 plus 0.007 plus 0.0006. And I get this here 0.328, which is 0.329. Because the 6 makes the 8 go up. And 0.329. And look there, we got it, man. That's right. This one says find the probability that x is less than 4. Okay, so less than 4 means I'm going to have 0, 1, 2, 3. Just those 4 right there. All right, so I still have this on my calculator, so I'm going to go back into it. Now, when I do 0 here, okay, there's 10. I'm wanting 0, and then my success is 0.48 to the 0 power, and my failure 0.52, and that'd be the 10 power, because if there's 0 successes, there's got to be 10 failures. All right, so okay, there you go, and I got 0.001. All right, now let's do this one. I'm going to just change my numbers. So, okay, delete this. Okay, this be 9, 1, 1. And there you go, 0.013. 013. All right, 2, which means that'd be 8. 2, 2. 0.055. And then 3 means that this would be a 7. That'd be a 3. And that'd be a 3. And let's see there, 0.136. And I add those up. All right, so 0.001 plus 0.013 plus 0.055 plus 0.136. I think I hit a negative instead of a decimal here. Okay, 0.205. 0.205, and oh, that says 207. Let's look at this again. Now, see here? Here's where, now it may take that, see, I rounded these. See, I rounded these each time, and then it was off just a little bit. It may take 205. It says 207, but it may take 205. If not, I would write this whole number out. Instead of rounding them, I would write the whole number out, or at least write maybe 2 or 3 more decimals. Write down 5 decimals of it is what I would do maybe. Instead of just writing 0.136, I'd write 136,435 maybe. Anyway, I'm right on it, just off a little bit because of the rounding thing. Okay, number 11 here is the same kind of question. I'm not going to do another one just right now. Let's go to this one here. This is the same thing here. 55% of consumers prefer to purchase electronics online. You randomly select 8 consumers. Find the probability that the number of consumers who prefer to purchase electronics online is exactly 5. So this tells me N is 8. My P is 55.55. Q is going to be 1 minus that, 0.45. That's a 0.55 right there. All right, and then in this one, x equals 5. So when I set this one up right here, the probability that I get 5 is going to be 8 NCR 5 times 0.55 to the 5 power times 0.45 to the 3 power. Since I have 5 successes, I have to have 3 failures. Okay, and that's how I set it up. All right, so let's see here. 8 NCR 5 times 0.55 to the 5th power times 0.45 to the 3rd power. And there we go, man, 0.256. Well, it rounds, look here. 0.2568, the 8 makes the 6 go up to 7. And then we see it right there. That's the right answer. Now, I'm not going to do all this, but right here it says probably that x is greater than 5. That means I'm going to have 6, 7, 8, 9, and 10. I've got, oh, wait a minute, I'm sorry, it only goes to 8. X is 8. Or N is 8, I mean. So I'm just going to do those 3, and I'll add them together. Okay, maybe I should do that one. So P of 6 is going to be 8 NCR 6, and then 0.55 to the 6th power, which means I have 0.45 to the 2 power. Since I have 6 successes, I have to have 2 failures. So I type this in. Luckily, I've already got it on my calculator here. And I'll just change this to a 2. Change this to a 6. Change it to a 6, and then there you go, point. Now, like I told you a while ago, 0.1569949. I'd write 6 decimals down. That way we don't round and get something differently. Okay, we'll go back. We're going to do P of 7, which means this will be a 1. This is a 7. You just change those 3 numbers, 7, and I get this 0.054807. All right, then we're going to do 8, P of 8. Okay, so I'm going to go back in here, which means this right here, this exponent's a 0. This decimal's, or this exponent's a 8, and that's a 8, which means 0.008373. And now I add all 3 of those up. All right, so 0.156949 plus 0.054807 plus 0.008373, and I get this right here, 0.220. And look there, we got it, 0.220. So yeah, leave your decimals like this. Don't round them when you get this. Leave them along, like maybe 6 digits or 7 digits or something. So when you add them together, there won't be any rounding that causes you to be off, like I was just a minute ago. 13, we'll just do this first one here. 46% of adults say cashews are their favorite kind of nut. You randomly select 12 adults and ask each to name his or her favorite nut. Finally, probably that the number who say cashews are their favorite nut is exactly 3. All right, so here, P is 0.46, which means Q is 1 minus that, which is 0.54. All right, N is 12, and for the number for part A, X is 3. So when I set this up, here too, right here. So when I set this up, I'm going to have n is 12, NCR 3 times 0.46 to the 3 power times 0.54 to the 9 power. And that's what I'll type in. All right, so when I do that here, 12, where you can see it here, 12 NCR 3 times 0.46 to the 3 power times 0.54 to the 9 power, and I get this point. Oh, I did 46, not point. I didn't hit my decimal. Insert a decimal there. There you go, 0.083, which is 0.84. The 6 makes the 3 go up to the 4. So 0.84, and look at that, we're good. All right, the other two. X is greater than 4, which means we can have 4, 5, 6, 7, 8, 9, 10, 11, 12. There's a bunch of them to do there. Right here, X is less than or equal to 2, 0, 1, and 2. There's 3 of them to do for that. Okay. Then we'll skip these. And let's look at this one here. Now this one, we've got this whole box. We got to do all of these and put them in the box here. Okay, it's the same problems we've been doing, and I think I'm not going to do them all, but then you have to select the graph. So just take your numbers here and the probabilities and see which graph looks like the numbers are right. And then as far as being skewed, now skewed left means it looks like this. You got your where you got a tail to the left. Symmetrical looks like this, maybe, where it's kind of symmetric. Skewed right means you got the big ones here, and then you got a tail over here to the right. Well, we drew them and you couldn't even see them. Sorry. There's the skewed left where you got a tail to the left. Symmetrical is where it's kind of symmetric. Skewed right is where it's kind of the tails to the right. Okay, and then values that are unusual, remember 0.05. If you have something less than that, is unusual. And that's what this is asking in part C. Okay, now there's another one like that. Okay, these are answers. Yeah. We'll get to this, I think. All right, the last ones are these. 78% of U.S. adults think that political correctness is a problem in America today. You randomly select 6 U.S. adults and ask them whether they think the political correctness is a problem in America today. The random variable represents the number of U.S. adults who think that political correctness is a problem in America today. Answer the questions below. All right, so P is right there at 0.78. That means Q is going to be 1 minus that, which is 0.22. And then N, we see right there, 6. Okay, so what's the average? Remember, this is N times P, which I just take 6 times 0.78. So let me do that here, 6 times 0.78. That comes up to 4.68, which rounds to 4.7. Okay, now this right here, remember, is N times P times Q. So do this times this times this, all 3 of them. So N 6 times 0.78 times 0.22. And I get 1.02, which is just 1. Then I do this, the square root of that for this. This is the square root of N, P, and Q. Okay, now I would just leave this. See, that rounds to 1 for this answer, but now I want to leave that on there and go with this, do the square root of that answer, which gives me 1.01, so it's still 1. And we're good to go. There's my answers. Oh, wait a minute. This part here wouldn't answer. Most samples of 6 adults would differ from the mean by no more than 1. See, this is my standard deviation to how much it differs. That's the standard deviation. Okay. And there's a few like this on here. Number 20, same thing. Okay, 81% of adults in a certain country believe that life on other planets is plausible. You randomly select 5 adults and ask them whether they believe that life on other planets is plausible. The random variable represents the number of adults who believe that life on other planets is plausible. Find the mean, variance, and standard deviation of the binomial distribution for the random variable and interpret the results. Okay, so we see here 81%. There's my P. P is 0.81. Okay, we've got 5 adults we're selecting, so that means N is 5. And Q is going to be 1 minus that, which is 0.19. So here's my 3 numbers. So right here, mu, that's going to be N times P. So I'm going to do N 5 times 0.81. And I get this here, 4.05. This is around 2 places. So there you go. All right, find the variance. So that's going to be N times P times Q, which is this times this times this, all 3 of those. So I'm getting 0.7695, which is 0.77. Okay, and then the variance. Now I leave this on there and do the square root of that answer. I don't want to do the rounded answer because it might go it off a little bit. So this is 0.88. This 7 makes the 7 go up to 8. Okay. So I remember now, I didn't write it down here. NPQ, this is the square root of that. All right. So we're looking good here. We got those answers right. We got all 3 of them right. Now what this says, on average, our average is 4.05. 4.05 out of every 5 adults in the country believe that life on other planets is plausible. In most samples of 5 adults, the number of adults who think life on other planets is plausible would differ from the mean by no more than, right there, 0.88. Because that's the standard deviation. That tells how much it differs. Okay. And then there's a couple more of the same exact questions here, just different kind of situations. All right, so I think it pretty much sums it up, I believe. Okay. Yeah. This is good too. Yeah, I'm done now. So here you go, Binomial Experiments. Contact me if you need help. Sorry the video's so long, but hopefully, you can skip over the parts that you need to and look at what you focus on things you need. So have a good rest of the day, all right? Bye-bye.